Okay, what we have here is a Heathkit IG102. It's an RF generator. It functions between 100 kilocycles and 110 megacycles, and it does so in 6 ranges. Um, we have a range switch, we have a vernier dial indicator, we have internal and external modulation and a control for the modulation output. If it's internal, you go 400 cycles per second. External, you can choose your modulating frequency. Here's your choice for internal or external modulation. We have a 3-position coarse attenuator and a variable fine attenuator for the signal strength. It is a nice looking unit. Very few faults in this unit at all. There is a fine scratch that runs about 1 inch long between the dial indicator here and here. I don't know if you can pick it up on the video or not, but there is a small surface scratch there. Outside of that, this front panel is in perfect condition. I have installed new style BNC connectors in place of the old button type. This gives you the capability of buying and utilizing the latest BNC connectors, which are cheaper than the older ones, and they function quite well. And it'll give you a larger selection, and you'll be able to adapt easier to your equipment. So, good reason to go for these type of connectors. We have an on-off light that's working here. You can see the ruby red indicator at the top is working fine. And then the cabinet itself is in very good condition. There is no major paint scratches of any type on this unit. No permanent ink markings, anything like that. So this unit is in fine condition. We're going to be running it through its paces here, testing whether or not the output of the unit is in good shape, and we're going to do so looking at it here on this B&K oscilloscope, 100 megahertz oscilloscope, and we're going to be looking for output through each of the ranges and see just kind of what the waveform looks like and that it's there. So as you can also see, we've connected in a frequency counter so that we can observe the frequency obtained out of the unit that we are also observing on the oscilloscope. So at times I'll be looking up at that just to kind of verify that that's what we are achieving. Let's go ahead and turn out the light. Give ourselves a good chance to see this thing on the scope, and I'll leave the light highlighting the RF generator so that you can see what I'm doing there. We're going to begin at the bottom of band A, and right now the lowest frequency I'm able to get is 95.2 kilocycles, it is. And that's the waveform obtained. Let's go ahead and we're going to run it up to about mid-band, and then I'll stop it again and we'll take another look. Alright, you can see our change in frequency. And I'm going to stop at roughly 170 kilocycles. According to the vernier dial, it's 170 kilocycles right there. What we obtained is 174.7, so 4.7 kilocycles more at the 170 range. Not bad. And we are running kind of high in our amplitude. The amplitude out of this kind of a generator is not a controlled amplitude, so you're going to see that the oscillator is more efficient at some frequencies than others, and you'll see the amplitude change. And that's why you have the fine attenuator adjustment here, that you can adjust the signal to the strength you want once you've attained the frequency you desire. So let's continue. We still have a clean signal, and we have 174.6 at the 170 mark. We're going to take it up to the 32, which is the end of the, this would be 320 kilocycles. This is the end of the 320 kilocycle band A, and there's a waveform. nice and strong. We are running at 320 and it says 324, so we're 4.7 kilocycles high at this point too. But 4.7 out of 320 is a small percentage. We're doing quite well at tracking. Let's go ahead and change to band. Well, let's go ahead and pull this thing all the way up. Maximum signal on this is 330.8. I can get maximum on that range. All right, let's take it back down to minimum again. Okay, we're on band B, and we are right now at the minimum side of band B, which would be 310 kilocycles. I'm actually at below that mark, and I'm running 298.9, so 299 kilocycles. If I put it on the 31 on this band, looks like it's right on there. And what I'm seeing is I get 305.6 kilocycles instead of 310. So we're running about 306 versus 310. We're about 4 kilocycles low at this point. Waveform looks nice. We're going to go ahead and take her up to about mid-band. Yeah, this would be about 550 kilocycles. And what I am seeing is 564.3. So we are 14 kilocycles high at 550. And right now we should be at 1.1 megacycles, according to the dial, the vernier dial. I can increase my frequency on my oscilloscope so we can get a better look at the waveform. It's looking good. We are running 1.092, essentially 1.1. So that's very good. And if I max it out, we get 1.10. So right where we wanted to be. Let's go ahead and step to the next range. Once again, we're at the bottom of band C. Band C is 1 megacycle to 3.2 megacycles. And at this point, we are reading, we are at the bottom of the scale. We're not even on a scale right now. And we are reading 943 kilocycles as our minimum frequency, and that's what our frequency looks like. So starting out at 1, that looks to be 1 right there. And I am reading 991 kilocycles, where I should be at 1 megacycle. So we are 9 kilocycles off of being perfect. Again, not bad when you consider that's 9 out of 990. Very good. Let's go ahead and take ourselves up to about mid-band. We should be reading about 1.7 megacycles at this point. I'm looking at the oscilloscope. I see that we've gone over scale. Let's bring her down a little bit. And we are reading 1.744, so 44 kilocycles above the perfect 1.7 megacycle range, but 44 over 1700, it's not too bad. Let's go ahead to the maximum. This would be 3.2 megacycles we should be reading. And again, I'm going to reduce my signal strength just a little bit, and let's go ahead and increase this so it's a little more visible. And we're reading 3.211, so 3.2 megacycles within 11 kilocycles. That's very good. And then our maximum at this point is 3.274. So we can get that on this band. Let's go ahead to band D. Start out at the minimum. Okay. Lowest frequency available on the band is 2.988, so 2.99 megacycles. And if we go to 3.1 on the vernier scale, we are reading 3.055, 3.06. And waveform is looking good. Go ahead and take ourselves up to mid-band here. This should be reading 5.5 megacycles. The waveform is looking good. Go ahead and increase this a little. We're reading 5.65. We are 5.5, 5.6. So P50, 90, 97 kilocycles over out of 5,600 and 5,500, 96 kilocycles over. Okay, so let's continue to. Okay, the maximum of this range D is 11 megacycles. I am set on the vernier to reach 11. I am reading 10.87. So that puts us within 130 kilocycles out of 10,870. So we are very close. And the waveform is looking very pretty. The maximum on this scale that I can get is 10977. So this would be 11 megacycles, which is really what we wanted. Band E. Take ourselves down to the minimum. And we are on band E. We are at the minimum that we can reach on the vernier dial, and we should be below 10 megacycles, and we are reading 9.36 megacycles. Nice waveform. Let's go ahead and raise her. We'll take her up to the 10 megacycle mark. I read that as 10 megacycles on the vernier. And we can see the waveform on the screen. It looks pretty good. We can step it up actually, make it a little more observable. And we are reading 9.834 instead of 10. 9.834, so 166 kilocycles away from the perfect 10. Let's go ahead and raise ourselves to mid-band. Mid-band, I read this as 17 megacycles. I'd say we'll reduce our gain a little bit. Okay. 17 megacycles, and we're reading 17.396, so about 17.4. Let's go ahead and take ourselves up to the maximum. This would be 32 megacycles. And the waveform is looking a little crowded. Let's make it a little more visible. Looks good. We are running 31.662 megacycles. And if we took this thing all the way to maximum, we would be reading 32.21. Alright, and then finally, let's take ourselves back down again. We'll go to the last band, which is F. Alright, and we are starting out on F at 3.2. There's 32 megacycles. It's our waveform of 32 megacycles. And we are running at a little above 32 on the vernier scale. Probably more like 33. If I take ourselves up to mid-band, I'm going to call it 60 megacycles. And so we are at 60 megacycles on the vernier. And that's our 60 on the screen. And we are reading 59.995. This is the closest we've been so far. We're exactly 5 kilocycles away from being a perfect 60 megacycles. So the vernier is accurate at this point, dead accurate. Let's go ahead and take ourselves up to the maximum. I see us, efficiency-wise, we're climbing quite a bit as we go up this this scale. So we want to go to 110 megacycles on the vernier. Vernier's reading 110. Our there we go. We've adjusted our frequency. How do I get? There we go, times 10. Just allowed us to see the frequency a little bit better. So the waveform is quite good at this point, and then if I go to at 110, I'm reading 111.2 megacycles, and if I go to the maximum side of the scale, I'm getting I'm getting 1.1170, so 111.702, 111.7 megacycles is the maximum frequency. So there we are. We've gone through all of the ranges, and if I do the attenuation, there's the mid step and there's the lowest step. And the fine attenuator we've been working with, it's continuously variable. Let's go ahead and get ourselves, there we go. And we have an internal modulator, like I said, that allows us to apply 400 hertz modulation to the signal. And then if you were listening to a radio and you had dialed into the RF frequency of the radio, you'd be hearing this tone coming out. So there we go. Along with this unit, we'll be providing this nice Heathkit service manual, a set of new leads, ENC type to gator clip. These are the most adaptable of the leads I could give you. And this service manual or kit manual shows you how to build the kit, takes you through all the steps, gives you some theory, explains how to calibrate the unit, explains how to use it in servicing radios, and then in the end we have the circuit diagrams. So you'll be having a complete kit in this unit. And happy bidding. Thank you for listening. Bye.